So every point, I mean, these two graphs here intersect at every single point, obviously, if they're on top of each other. Let's construct actually, we'll just start over here with a new screen. And what I'm going to do here is I'm going to construct a system that has an infinite solution set. Let's say we had x plus y is equal to 10. Now, I'm going to multiply, let's say 3, it doesn't matter, we multiply a number all the way across, and let's say we have 3x plus 3y is equal to 30. Well, it turns out these are, if we were to graph each one of these individually, it turns out that they'd be the same graph. And so, in other words, basically, is what we're saying here is so this would be like the line to this equation, and then if we were to graph this equation, it would just graph right over the top of it. So you see, we'd have an infinite solution set. Now, if I were to solve these systems, we would do something like, like I've been doing. I would solve for x in this problem, let's say, and so we'd end up with x is equal to 10 minus y, and then I would take this and plug it in for this x, this 10 minus y. So we'd have 3 times 10 minus y plus 3y is equal to 30, and of course we're wanting to solve for y in this problem, so let's see what happens when we do this. Alright, so the y's cancel out, negative 30y plus 30y, they're going to cancel out, and we're going to be left with 30 is equal to 30. So you see both sides of the equation are going to be equal to each other. Okay, and this is going to be a clue here that there's an infinite solution set to this. Alright, whereas remember in the previous problem we got something like this where these weren't equal, which means no solution. But if they are equal, then that means there's an infinite solution set. But usually what you'll be able to do is, for example, if I multiplied 1/3 all the way across inside here, we end up getting this equation looks exactly like this equation up here. Alright, so good luck, get to the website, practice some problems. Alright.